So I will make the next presentation. It's about a similar topic because it is a part, a sub-part, a part of the project presented by Silvia Orlandini. We want to achieve the interlinkage between schemes, between proficiency testing schemes around the world. And we want to interconnect these national or local, regional PT schemes to an upper level, which is expected to provide so-called truths or true values to the routine algorithms through the reference labs, which can serve as relays to their countries. So we'll give an overview about the issue. The different parts of my presentation will be these ones. First, the reference in the AQA system. Speak a little bit about the relativeness of the reference. That's a tough issue. The choice we can make, how to link the proficiency testing schemes, the different levels where we can implement the schemes, and the example of the application is multi-cell counting in the frame of the system which is undergoing, the development is undergoing now. Then to conclude. At first, the reference in the ICAR that you all know, that ICAR needs to know the true contents for milk recording, and it needs to establish it for all in such a way that every organization or ICAR can provide and produce DHA results on the same scale. So ICAR has described and stated its methods in guidelines. The reference must be produced thanks to internationally standardized methods, or could be also be produced by standardized method, tightly fitted and accurate to the internationally standardized methods. So anyhow, everything revert to the international standard for the reference methods. But the point is that the reference methods are slow, even if automated. They are slow, still slow. And only routine methods, quick rapid routine methods such as Minifred or cell counting, automated cell counting, can be used. So the point is how to calibrate and with which kind of reference we have to calibrate. There are two ways to calibrate. Of course, we focus on reference methods, but who use the reference method? The laboratory itself. So that's an individual calibration. We'll see it's maybe a little bit poor. Or a centralized calibration, which provide more robust reference values, always with a reference method. And also, in this definition, we have to secure the DHA analysis through quality control, which has been described in the guidelines of ICAR. So we have the internal quality control and external quality control. And our main focus more to external quality control so as to quantify all the system. And every part of the control deals with reference and routine methods. So our focus is the reference methods and external quality control. What about the relativeness of the reference? So what is, where is the analytical truth? Big question. Truth is stated by the reference methods, but it is a relative concept. The reference method provides results with uncertainty. That's evident for us, but not for all. Many people think, I carry out a method, I have a result, it's the right result. No, that's status quo uncertainty. Maybe it's not so small. So when we develop a method and we standardize the method, there is a characterization of the method through the precision characteristics, which includes repeatability, So the tightness of a replication reduces to in short delays of the replication of the same sample. And the reproducibility, which is almost the same, but we replicate analysis on the same sample, but in different location, different time. The same method, but it can be different device. So there's two extreme possibilities of replication. And in the reproducibility, that a major part, which is understood in this, that's the difference between laboratories. Stating these values, the standards state also the difference which are acceptable between labs. So this defines also what is permitted when you control a laboratory. You assess the performance of laboratories. We should define limits. And fortunately, we can do thanks to the standards. Fortunately or unfortunately, depending on how is our taste about the limits we are setting. So from the method we are concerned with, we are fat, protein, somatic cell counting. That's for genetic. I don't deal with urea and lactose for the moment, but it could be. You have the first columns till big R relates to the values that are contained in the standards. That's these values that should be used by the laboratories in the field of their accreditation or across guidelines of ICAR. And big L and plus or minus sigma L, which is a standardization between laboratories, and big L is the maximum range between two laboratories, which we are able, as a maximum, to observe in 95% of cases. So you see that these values for fat, 0.04, between two labs, is not negligible. And the same for protein, 0.03, it's not negligible. Even more, if we are considering we could also work for milk payment. That's another issue. But this makes significant bias between laboratories, which are projected to the routine method calibration. So we have already, at the beginning, a maximum difference of this type. And speaking about somatic cell counting, this is much, much larger. So these are the official values stated by standards. But in the real life, a number of laboratories are not within the limits. They can pass through, be outside the target. So we can imagine that we have a problem somewhere, but maybe it can satisfy people. But for technicians, we are not satisfied with this. That we are willing to improve it a little bit. So range it out between two laboratories chosen at random. And this is the range for a population of laboratories. Plus or minus 0.03, plus or minus 0.25, plus or minus 81,000 cells, or plus or minus 10%. That's not small amounts. So the point is to reduce the variation through averaging and move to laboratory networks. That means to produce reference through the means of laboratories. But doing this, moving to the reference produced by a group of laboratories, a network of laboratories, is it also valid? In fact, every national network or any network of petty streams defines its own reference, because it is the average. So the results defines the reference. That's not an absolute reference. And no one knows whether it differs from the others. So, and even not know how far it differs. We have no means to measure it. We had no means till now, but we're starting to have a mean now. So all these national networks, A, B, C, D, E, are they equal with regard to the reference? That's the question. Assumption that the group gives a true reference is totally relative, because we have different conditions of inter-laboratory studies with regard to lab, PT design, protocol, method involved. All this can influence the population results and also the reference which results from all these results. So before moving on, I want to make a recall about what is measured in PTs, and in the presentation of PTs I will present thereafter. We are measuring the systematic bias of each laboratory, and it looks a little bit like a calibration curve that you see. In ordinate is presented the reference values, whatever they can be, produced by the reference method in the laboratory or through the average of a group of laboratories. This is the true values in brackets. And in abscesses, this is values obtained by the laboratory. So the laboratory is assessed against the reference. So in the below, in the low part, you have the mean bias, which show the error, mean error of the lab. And the top, the standard deviation, which is the variation of the individual biases. Individual biases will produce a mean bias. So these two values are producing the score. The two values that can allow to evaluate how well a laboratory can work. There are other statistics, but they are the simplest, the basic ones. So this is a target figure that are typical and presented for each international or national proficiency testings. This is a RICAR presentation. It has been published in IDF bulletin and it can be used efficiently. And the mean deviation, the mean bias is represented, here the standard deviation is represented here, and the mean bias here. So what is in the calibration figure is reported in the target figure where all the labs are gathered and can be compared. So this is to make you more familiar with the presentation, to prepare you, condition. Now, I will speak about the relativeness of the reference produced by a group of laboratories. This is the typical presentation of a regular PT scheme. I will not say which one, those who knows can recognize. And in this scheme, we have different average, small square, triangle, and diamond. So this corresponds to the reference or the mean values obtained by the labs of the country in green, and the blue one, the foreign labs that do not belong to the country. And for protein, you can observe a bias over than 0.01, closer to 0.015. So even there, it is a significant bias. Maybe not for genetic, but when you speak about trade of milk products, it can make some kind of million euros sometimes for a country, or billion, depends. Because these are systematic bias. We must be very careful with that. Fortunately, ICAR, Laboratory Network, is in the middle, by chance at that time. The next example, somatic cell counting. There are very new proficiency testings, the more recent ones. Same country labs are on the right side, not far from the middle. Foreign labs are a little bit further, but on the left side. ICAR much further on the right side. So the range between the extremities are more than 60,000 cells per milliliter at a level of 700,000 cells. So that's a good illustration of our issue of somatic cell counting, and that shows well that we had some need with regard to the reference. Normally, if all groups would deliver the same reference, we should have all the groups close together, not separated. So, as an example also, This is 3 PT schemes existing in Europe that already, the results have already been presented 2 years ago. That's all to show the diversity of the protocol the PTs has been organized with. Scheme A, we have a 2-level experimental design. 2 samples with 5 replications at each level and several samples at each level. Scheme B, you have 5 levels. Some are overlapped. And you see only 3 levels, but there are 5 samples, and the replications about 2. And after you have another scheme, we have 10 levels. 2, 5, 10 is quite different. And you see that the range covered are not the same. The first range is about maximum up to 100,000 cells per meter. The second one goes up to 600,000 cells per milliliter. And the last one goes up to 1.5 million cells per milliliter. So it's quite different. And you can look at the distribution of the laboratories. They are quite significantly different on the figures. So in our mind, we would like to compare all these schemes, but to compare them, we do not compare the same things. We have a problem at the origin of harmonization, but that's only a point we keep in memory for the conclusion thereafter. The first scheme, the simplest one, shows a very good precision and distribution in the target expected for the acceptable values. Most of laboratories are within the target. Second one, not quite different. A lot of the laboratories are outside the target. This is the same target. I mean, everything is comparable. And another figure, it looks like a little bit with the former. This is one of the middle, but different. Standard deviation seems to be lower in the middle, and there seems to be a relationship between the standard deviation and the means. So they have a meaning for statisticians. Many slope defects. This is the meaning. So you see that the protocol may have an influence on the results, the shape, and probably also on the position of the reference too. So we move on to the choice for a new universal reference. So this last picture we already seen formally. That's what we would like to do. We need a unique origin for a reference, but also we need this reference to be worthwhile. You can trust in them, have full confidence. So we need a kind of political representativeness and regional representativeness that everybody can recognize this reference. That's much important for general use of a system, but also beside this representation, everything must be perfect. So laboratories must be quite good experts, produce very good results. So to be well trained and so on. So truth is an agreement of all stakeholders to reach common goals in general. And for ICAR, it's a harmonization worldwide. And the ICAR choice at the present time is for the values delivered by the International Reference Laboratory Network. International recognition is willing through the representativeness, and highest competence and training is wished. So we need suitable methodology and very good capabilities of the labs. Also, we need a good technique to link. If not, nothing will be perfect. What is a principle which has been developed? We are starting from the idea that the reference of different PT schemes are different. They may be different. So we decide that we rely on a reference provided by one of the PT schemes. for us, it will be the ICAR network will produce the good reference. And we can imagine this is the network B, which produces the reference B here. For lab H, which is assessed in the PT stream A, there is no direct link to B. That's a big problem. And we want to overcome this barrier, I would say. But we have, fortunately, reference labs which participate in 2 schemes. We expect there is no change in both participation with regard to the quality of the results. And the best is when there is a simultaneous participation. We need to calibrate or to align the reference A onto the reference B. Why? Essentially because the samples of the PTs A are not the same as those of the PT B. So we have to predict what would be the reference values of the samples of the first PTs in the frame of the second PT. That's something we must understand. It's not so easy. We know that through the first PTs. We know that from the second one. So combining the 2 relationships, we get this. And we reach the goal. Normally, everything can be solved by simple linear regression. So this is easy mathematics. We could go to polynomial regression, but no real need. If there are linearity bias, they are not frequent and not so, well, we could do, anyhow, but linear model works quite well. So first, define this equation, simple equation, the reverse equation for the first PT, combination. Then, from Y, the real reference of scheme A, we can put Z, the virtual reference of scheme A in the scheme B. And in case we have no level effect, so the method is not level related, it's only a point of addition of constant, and we revert to the relationship which has been presented in in Niagara Falls 4 years ago. So this is a general model which works. So how to implement that? Well, Sylvia showed us that a number of PT schemes available or working, running in the world for somebody accounting. We can imagine there is this circle here, and in the middle, each of their reference may be different or the same. We don't know. Anyhow, there is no connection yet. So first step is to connect them, to have laboratories participating at the same time, commonly in both trial 2 by 2. So we create a network. So at the level of nation, of countries or region, whatever can be the reference, we should decide what is the reference. We could strive to align the different PTs at the same level by 2 by 2 comparisons and agreement on a reference. Second way is to define that there is a PT scheme with more traces than another, which would be referred to as a reference PT, an intentional PT scheme. And through reference directories, again, we interlink which to a single PT scheme. So it's what we call the anchorage of all the directories to a single lab. A single PT scheme. And this is a model of ICAR with the International Reference Laboratory Network. So all this is beautiful theory. What is the result in the practical life? So this is a picture of the distribution of the results of the reference laboratories of ICAR network. This is the results in September 2009. So the coverage is a total for the range from 0 to almost 2 million cells per milliliter. So the need for cow, sheep, and goat are covered. So at the same PT scheme, we have had this kind of scores from the reference laboratories. And among these scores, you see that not all are the target at first. But among all these scores, you have 3 laboratories we have retained. These are the reference laboratories which are aiming or working in the national schemes A, B, and C I formerly presented to you. So they are connected to their national PTs. So this picture has already been shown at the beginning. But you can note that the position of the laboratories are not identical in scheme O and scheme CAB. But at first glance, it's only an observation, not only to present you how the system can work. Here is the way how a laboratory, for the example, it is the reference laboratory B, of scheme B, change of position when it is aligned, when the reference is aligned onto the international reference. And the yellow spot is the original score is a national scheme. The black spot is the position in the international scheme. And the white spot is a new position after anchoring the national PT and transforming the reference onto the reference of the international scheme. So we see that the reference of scheme B, scores is improved and much narrower to the center. That's the objectives of the operation. And we know that the standard deviation is much lower, simply because slope defect has been corrected through this kind of calibration of the reference. So doing this on the reference labs, we can do it on all the labs. So if the original scores in the national PTs are these figures, then after interlinking and anchoring, you have a new figures. This is the evaluation of the labs of the PT scheme B versus the reference of the international PT. So that can give the impression of what is the reality. Does it the first figure the reality or the second figure? The point is that we must have a full confidence in the quite good results of the laboratory B. That's essential because it serves as a bridge, and if bridging is not good, the results are not good, it could bias the whole population. So the system must be secured. That's why I said that these bridging laboratories should be reference laboratories and expert laboratories. It's the essential point in such a system. But we know it can be covered. In simultaneousness of the trials, when you analyze the same time samples of the two schemes, there is no bias possible. So the bridging is automatically realized. And the competence is only to be well repeatable. So if the two PTs are not organized at the same time, thereafter, then a special competence relies for this laboratory to maintain its calibration just identical during time. This means this laboratory cannot afford to follow the common rule that allow a range of variation between laboratories. he must keep on always on the same level through a net of control, reference materials, in-house reference materials. This is possible, but it is a special capability to develop. Local PT studies can show only a part of the problem if there is no external input through reference PTs or MS to give the truth. So that means that if there is no external information given to the PTs, the national PTs, he cannot know what is the reality shown on the right side. So we need some external input, and ICAR can provide this external input information to laboratories and to ICAR organization. This figure is a repetition of figures already shown, but the point is that we have the different location of lab B, and we can see that they are quite different in the different PTs. Explanation is that they are not all simultaneously realized. But if we would like the system works, the position should be the same. But also the protocol should be the same. So the protocol, you see the different levels of cells, the number of cells influence a lot of the scores. So the consideration here is RefLab should have the same scores in standardized condition, FNHCs and PTs, but only if everything is standardized. But the question is, the RefLab and other reference still questionable. So this is the last example. Through Anchorage of 3 PTs, we can make an evaluation of laboratories who works for specific purposes. Our concern is DHA. So from these PTs, we have taken the number of labs who are operating for DHA, and we have put the scores on same figures, same target. On one hand, without any international alignment, so these are the raw scores in their PT streams. And beside, after having aligned the reference onto the international reference of the ICAR reference laboratory network. So that means that maybe Surt was familiar with statistics, knows ANOVA. We introduce another source of variance, the variance between networks, that did not exist in the example on the left. And when nothing is perfect, and if all the things are perfect and well done, normally there's no change with aligning to the international reference. But if there are differences between PTs, there are broadening of scattering in the figures on the right. So that's a way to see if different PT streams works appropriately or could improve a little bit their reference. And if they want to improve their reference, they have to improve the scores of the labs. So that's a general approach, not only the system, but the labs have to get some information how to improve their method performance. So normally, lab scores scattering would stay unchanged if RefLab would have the same score in harmonized PT conditions. So to state that the quality of the work of the reference laboratory is quite essential. If not, you can produce a bias. You must be careful of that. So, still the question of the reference laboratories and or the reference. To finish, we are used, or organizations are used with ranking tables. So ICAR also has produced in the past and still produces ranking tables according to the best score obtained. So we could do the same by merging different results of different PT schemes. That's a way to compare labs. What has been done there? That's not to scrutinize the data, it's impossible, it's too small, but to show you that we can also do that and produce an evaluation, and thereafter discuss, improve, and so on. Whatever we can decide. That's still under development, so. To conclude is that, at first, there are prerequisites for international lab anchorage and intercomparison. We need an international network of national expert laboratories. The example of like a reference lab network is there. The ref lab needs to acquire high skill and competence. We look for high stability and performance, constant low bias and low repeatability. Tight anchorage through a net of reference materials and proficiency in STEM trials. Also, take care of simultaneous or close participation of expert labs in the international, in national PT schemes. This is a complementation of high performance of the lab. Anchoring labs to a national reference and comparing them to a unique scale is possible. And these PT schemes are appropriate tools, and they exist, as shown by Sylvia. But unfortunately, they work still independently and apply different protocols. So for ICAR to establish new guidelines to harmonize and enable comparison and fair lab performance evaluation. And also need to state the primary caution of such a system. So to establish new guidelines for that, so as to assure trusted correspondence between teams. Thank you for your attention.